Imagine this. The year is 1998. The early internet, a digital frontier of forums and chat rooms, receives a visitor unlike any other. A man calling himself John Titor appears, claiming to be a soldier from the year 2036. He is on a mission, sent back in time to retrieve an early computer model. His story is not just a simple claim, it is detailed, intricate, and captivating. He describes a world ravaged by future conflicts and a society struggling to rebuild itself. His presence on these digital forums sparks a debate that continues to echo through the corridors of the internet even today. Was he a hoax, a storyteller, or something more? Titor did not come empty-handed. He brought with him schematics and descriptions of his method of travel. He spoke of a device, the C204 Gravity Distortion Time Displacement Unit, supposedly built by General Electric in his future timeline. This wasn't a sleek silver pod from science fiction movies. Instead, he claimed it was a heavy, cumbersome machine installed in the back of a 1967 Chevrolet Corvette. The machine worked, he explained, by manipulating gravity. It used two micro-singularities, tiny, powerful points of immense gravity, to bend the fabric of space-time and allow him to leap across the years. It was a fantastic tale, blending the mundane with the truly cosmic. The details were what made his story so compelling to so many people. He described the physical sensations of time travel, the immense gravitational forces, and the precise calculations needed to avoid arriving inside a solid object. He explained that his machine had gravity sensors to lock onto the local space-time coordinates, ensuring a safe arrival. He could travel up to 60 years from his own time, but each jump was a risk, a delicate dance with the laws of physics. Then, as mysteriously as he arrived, John Titor vanished from the internet, leaving behind a legacy of questions and a tantalizing glimpse into what could be. His story forces us to ask a fundamental question. What if he was telling the truth? What if time travel is not just a dream, but a future reality? The idea of a machine that can bend gravity and traverse decades is a powerful one. It taps into our deepest curiosities about the past and the future. While the story of John Titor may forever remain unproven, it serves as a powerful thought experiment. It invites us to look up at the cosmos and within the laws of physics themselves to find out if such a journey is even possible. The journey to understand time travel begins not with a mysterious stranger, but with one of the greatest minds in scientific history, Albert Einstein. His theories of relativity completely changed how we view the universe. Before him, we thought of space and time as separate, absolute things. But Einstein showed us that they are woven together into a single four-dimensional fabric called space-time. And here's the amazing part. This fabric is not flat. It can be bent, stretched, and warped by matter and energy. This insight is the first clue that time might not be the constant ticking clock we perceive it to be in our daily lives. One of the most profound consequences of Einstein's work is the concept of time dilation. It tells us that time can flow at different rates for different observers. There are two primary ways this can happen. First, through gravity. The more massive an object is, the more it warps the space-time around it. Imagine placing a bowling ball on a trampoline. It creates a deep curve. A massive object like a black hole does something similar to space-time. If you were to hover near a supermassive black hole like Sagittarius A at the center of our galaxy, time for you would pass much slower than for someone on Earth. A few hours for you could be years for everyone else. The second way to slow down time is through speed. Einstein's theory also says that the faster you move through space, the slower you move through time. Nothing with mass can ever reach the speed of light, but as you get closer to it, the effects become dramatic. If you were on a spaceship traveling at 99.9% of the speed of light, time would slow down for you immensely. For every 1 year that passes for you on your cosmic voyage, more than 200 years could pass back on Earth. You would, in effect, be traveling into the future. This is not science fiction. It is a proven consequence of the laws of our universe. We even have real-world time travelers among us, though their journeys are far less dramatic. Astronauts aboard the International Space Station are orbiting Earth at about 8 kilometers per second. This incredible speed, combined with being slightly farther from Earth's gravitational pull, means they age just a tiny bit slower than we do. After a 6-month mission, an astronaut returns to Earth having aged a few hundredths of a second less than everyone they left behind. It's a minuscule amount, but it is measurable proof that time is relative, and they have traveled ever so slightly into our future. If traveling to the future is possible according to our current understanding of physics, a bigger question looms. What about traveling to the past? And if that is possible, why haven't we been visited by tourists from the future? This puzzle has intrigued scientists and thinkers for decades. One of the most famous attempts to answer it came from the brilliant theoretical physicist Stephen Hawking. In 2009, he conducted a simple but elegant experiment. He decided to throw a party complete with balloons, champagne, and a grand banner that read, "Welcome Time Travelers." It was a party for a very exclusive guest list. The clever part of Hawking's experiment was the invitation. He didn't send it out before the party. Instead, he waited until after the party was over to publish the invitation, complete with the exact date, time, and coordinates of the celebration. His logic was flawless. Only someone who could travel back in time would be able to see the invitation in the future and then attend the party in the past. So, on the designated day, Stephen Hawking sat in the room and waited. He waited for a knock on the door for a shimmering portal to open for someone to appear from tomorrow, but no one came. The champagne remained unopened, and the room stayed empty. The result of Hawking's experiment leads to several fascinating possibilities. Perhaps the simplest explanation is that traveling backward in time is just not possible. The laws of the universe might have a built-in rule that prevents it, protecting causality and preventing paradoxes like the famous grandfather paradox, where you go back and prevent your own grandfather from meeting your grandmother. Another idea is that time travel to the past requires something we have not yet discovered or cannot yet create, such as a stable wormhole. Wormholes are theoretical tunnels through space-time, but our current models suggest they would be microscopic and collapse instantly. There are other, more speculative theories as well. It could be that time travel is possible, but it is a highly guarded secret, classified by future governments to prevent catastrophic changes to the timeline. Or maybe there are strict rules, a kind of temporal prime directive that forbids travelers from revealing themselves to past civilizations like ours. They might be here, observing us from the shadows, hidden in plain sight. Until we have definitive proof one way or the other, the silence from the future remains one of science's most profound and tantalizing mysteries. The party is over, but the invitation is out there forever. The quest to understand time travel is more than just a scientific curiosity. It is a reflection of our own human nature. We are storytellers, dreamers, and explorers, constantly looking beyond the horizon of the present moment. The thought of witnessing history firsthand or seeing what becomes of humanity is a powerful motivator for innovation and imagination. Even if we never build a time machine, the pursuit of that knowledge pushes the boundaries of our understanding of the cosmos. It forces us to grapple with the deepest concepts in physics, from the nature of gravity to the quantum realm, and to ask what is truly possible within the laws of nature. The science, as we currently understand it, leaves us with a thrilling mix of possibility and mystery. We know that journeying into the future is a reality, demonstrated by every satellite in orbit and every astronaut who returns to Earth. The path forward in time is paved by the principles of relativity. The road to the past, however, remains shrouded in fog. Is it blocked by insurmountable physical laws? Or are we simply missing a key piece of the puzzle, a secret ingredient like stable wormholes, or an unknown form of energy? The answer lies somewhere in the unwritten pages of physics, waiting to be discovered by a future generation of scientists. Exploring these ideas is not just an academic exercise. It inspires us, it fuels the stories we tell, the movies we watch, and the dreams we have for the future of technology. The legacy of John Titor, the elegance of Stephen Hawking's experiment, and the mind-bending implications of Einstein's theories all contribute to a grand, ongoing conversation about our place in the flow of time. These stories and experiments are like beacons, illuminating the vast ocean of what we do not know. They encourage us to keep asking questions, to keep searching, and to never stop looking for the next great breakthrough that could change everything. In the end, time itself remains the ultimate frontier. We are all time travelers, moving steadily into the future at a rate of 1 second per second. But can we ever hope to steer our own course through the river of time, to visit its distant shores in the past, or its uncharted waters in the future? We don't know, and that perhaps is the most exciting part. The universe has not yet revealed all of its secrets. The book of time lies open, its future chapters are still unwritten, and the greatest adventures may be the ones that are still waiting for us somewhere in space-time.